Welcome everyone to the next multi-network community sync. Today is January 22nd, and we have some topics from Lionel. I don't have any other topics. Doug, I see you around. Last week we pulled your topic in. I'm not sure you were able to catch up on the kind of.
I saw the notes, but I didn't watch the recording yet, even though it looks like it's really worth it. So I can do that, or if there's anything you wanted to specifically know.
I think we can give highlight after a bit, and if you have any other questions, we can get back to it a bit if you want to.
Okay,
I
cool.
think we did. I think we have a common understanding, like at least with some the folks that were last week. I think the understanding of what we want to do, get out of the default network, and yeah. All right. Any other topics, folks? Let me maybe link the doc if anyone wants to add themselves to the agenda to talk something about stuff. So let's feel free to just add yourself. Yeah, Lionel.
Yes, thanks. So the first topic is about scheduling and the thing that I mentioned last week about the problem that we encounter in the CNIDR driver because of the current features in GRA. So the idea was to consume a device or create device on top of other device, or create virtual devices and consume some of the resources that are existing on this device. So, for example, bandwidth or IPs, etc. So I discussed with some people from IBM about this problem because they wanted to help on the CNIDR driver, and they created a draft document for potential CAPE to improve the array about this. And I just wanted to let this group know that this might be interesting for us
But
to
I
contribute
think
to.
is that the one that the one you linked here?
Yeah, I think so. Yes.
So one thing I want to call out, something that we did, because that's something that you brought up, right? What is your take on our kind of feedback on that the claim should only contain resources that we want to get? Because, and correct me if I'm wrong, this is what we called out. You should not call out a resource that you don't want to take. So in my claim, I should not say, oh, I want to use this parent device. You're not going, the pod is not going to call it. I'm not going to use it in any ways because it's just a parent interface. I'm going to create a virtual on top of it. And for that reason, you should not reference it in the resource claim. Is
But
that the understanding, or are you thinking it has to be called out in the resource claim?
but I mean, to me, it has to be in the resource claim. Otherwise, maybe I missed some parts. But you need to make the scheduler understand where you want to schedule your pod for this virtual interface based on the master node on the master interface.
No, so this is where your configuration, I agree, this is where your configuration comes into play. I agree on that part. But no, my problem is you should not treat the parent as a resource you want to call out as a reservable thing. That's my problem. And this is where I'm getting, because there are two things. Yes, I agree with you. I want to have the configuration of my parent. Yes. So either I do it through the because you have two places, right, that we called out. Like, let me get back to here. Either you do it in the template, because per interface, per, let's say, pod network, you would want to have a different pod network pointing to different parent, right? Or even or in the device class, if you will. So right, so it's up to the implementation. But then in the struct, you would provide, I want this network to point to the parent X, but I'm going to reserve only the virtual as a resource that I'm going to claim, not the parent. Is that because otherwise, if you would want to reserve and call out I want to reserve the parent as well in the claim itself, that kind of I'm not sure whether that's called, because you don't want to reserve it. You are just calling it out to ensure that it's there, but you will not reserve it, right? Or are you
Right,
saying
but you still
that you
need
want
to say you still need to indicate that the parent should be existing on the node where the resource claim will be scheduled on.
So this is where, of course, the array driver, the resource slice comes into play, and your implementation of how you manage the resources, right? Oh, I have a template, or you say that it shouldn't be based on a template. That, I think that's what you call out, right? Because this is where I would think that would be going. That's a fair point. Like, I look at the resource template, right? And I show you where the specific resource based on that template is available, right? So I think that will be the dependency I'm looking at, right? Let me maybe explain more. So I have a resource template with the configuration pointing to the specific parent interface, right? But then the my implementation will have to, let's say my scheduling controller, right, or agent on each of the node for the scheduler stuff, right, would have to look at those templates and say, oh, you want a resource that is going to be parent of interface X, right? So now I have to have that knowledge to indicate that your resource even exists, right, based on whether the X parent interface X even exists on a specific node, right? I think this is what I'm thinking, how I would go about this. But then you're saying you want to be more generic and explain and maybe give me some explanation more here on that. There, you would have your resource list out the parents and how many, let's say, virtual interfaces it can create without any other inputs. Is that correct?
Yes. Yes.
And then based on that, the scheduler could say, okay, I see that point. Okay, so then you don't rely on the existence of the template itself or the resource claim, whichever you create. It's right away, it's already prepared. Oh, I see. And that's a fair point. Now I see your point of view. Okay.
I'm
Because
not exactly sure about the point that you mentioned. Are you saying that the driver is implementing the scheduler part?
yes, why? Who's doing that? Yes, the resource slice, creation of the
Right,
resource
the
slice
resource.
has.
Yeah.
Who's
Yes.
creating the resource slice?
Yeah, it's or the GR driver or some third party component.
And I'm not saying it has to be the driver. Yes, I agree with you. I'm just calling out the implementation. Let's call it more generic, right?
Yeah.
The
Okay.
provider of the driver has, let's say, it might have the driver, and it might have a daemon set across the nodes to create the resource slice across the nodes based on whatever it is designed to do, right? That's what I'm getting at, right?
I'm asking this question because I thought you were referring to I think it's called the classic DRA, where they had this API like it was the scheduler
No, and it's
calling.
not what you're saying.
No.
Yeah. I know what you're saying. That no, that's not that. I know. No. It's not
understand.
that. The daemon said the agent that is responsible for listing out resources. I would imagine that guy just watching the templates, right? And based on that, it will just know what sort of resources I want, right, or I don't. But keep in mind that now your agent, your scheduling agent on each node has to predict what sort of resources I might request. You see that, right? So basically I have an interface, and let's say this is a PF, right? So what you have to account for is that PF can have virtual interfaces, all the type of virtual interfaces I can think of or you support, right? So let's say you can think of, like, I don't know, IP VLAN, MAC VLAN, a bridge, you name it, right? You have to come up with all the possible combinations and list them out with that approach. That's something that needs to take into account. Then you might be a VF, right, as well on top of that, and then I think a PF, right, as the whole thing is going to be as such, right? And then your agent will have to list out, okay, those are the type of resources that my implementation supports, right? And then I expose those type of resources. I think that's what it boils down to. But then what I was thinking is, instead of you doing all the possible combinations, the template tells you, okay, I would want to use it in that way. So which one of the resources has it, right? So that's what I was thinking. The agent would listen as well on the templates to see, oh, okay, you want that specific combination of the usage. Let me list it out for you, right? So instead of that was my first option that I would think that could go. But I see the problem with that, right? Because then you assign the template, and then you will have a delay, right? Because you create a template, then you have to wait for your agents to catch up on the template, and then only then you can schedule a pod, right, to it. I think on the other hand, this is why I do want to make sure the pod network, the object for pod network, has a gating mechanisms, right? So basically, in terms of readiness, for explicitly for such purpose, right? Where I will create a pod network and I wait until the whole cluster is, let's say, reconciled in full, right? And that would mean as well listing out all the resources for that pod network on a specific, of course, accordingly, right? Each node, depending on whether they have found the resource or not. Yeah, because otherwise you have to list out all the possibilities, all the combinations of all the resources and all the interfaces on the node, right? You see that, right? And that's then if you go by just blank slate, okay, I need to list out all the possibilities I can create here.
Right.
That's the trade-off, right?
Yeah,
I
but
think
I mean the idea is not to list all the possibilities, but to list everything that is available on the cluster, and then from a resource claim have the possibility to use them and consume them instead of claim the entire device. So I can
no,
use
that's perfectly fine. You can as well,
Yeah.
as I said, you can draw it up the way you wish it, right? Keep in mind that I can set, let's say I can create a pod network that is going to be pointing directly to the PF. I can have that, and then my scheduling agent looks at such pod network and sees, oh, okay, you want the whole resource. Okay, so let me see which node on my node. Okay, because it's per node, right? On this node, do I have such resource? I don't. Then I will list. I will not. My resource slice will not show anything because I don't have anything, right? And this is done by every agent, and then some will show, some won't, right? That they do have it or don't, and that's how it's not instant as you it almost instant, because keep in mind you would create the pod network, we create the template, and then everything just reconciles. I don't think that would be a heavy kind of operation to do, to just check whether I have specific, let's say, PCI device or what's not. But then you have it event driven rather than bulk calculation of all the possibilities that I can have, right? I think that's my thinking. And I see if you go with bulk, then yes, you have to call out, okay, this parent, I want to maybe not reserve, but in this case it's a virtual, I want to put a hold on it as well, right? That, okay, this parent now is, I have a virtual interface on this parent, it cannot be anymore used for a PF, right? That's definitely has to be somehow.
Right. Yes, I agree with this.
Isn't that done by infer? Because that will be strange if I have to call out a parent. Is that not part of the virtual enhancement they want to create, Lionel? So because right now I can create a virtual resource out of a parent, right? Won't that be like infer
No.
that if there is a resource use from that parent, you cannot use the parent for anything else? This should be like a built-in capability of the scheduler in the array. Beside, because I should not need to call out, oh, I need to put a hold on this parent because I need this virtual out of this parent. This should be like infer, because that's obvious, right? I want to use, okay, how do you specify which parent do I want to use? Okay, this has to be somehow, no, it doesn't have to matter, because let's say your implementation knows that if I specify this specific virtual interface, it is of that specific parent. So this should be inferred that, okay, if you do this, I will put a hold on your parent as well. I don't think that should be part of the configuration. That should be like a built-in kind of capability of the DRA. Don't you think? Because this is all kind of obvious, right? I am using this virtual child of this parent, so put a hold on that parent. I shouldn't be explicitly.
But this feature of virtual doesn't exist yet, right?
Sure, this is isn't
I mean,
that, but there's a cap for that, right?
That cap that I mean, to my understanding, this cap is about this special use case, so it should also cover this.
And because I think in the past you did call out the virtual, but do you see my point on the parent?
Yeah, right.
Exactly.
Yeah, I mean,
right?
this should be, it should be handled. But
so
yeah,
and
I think it should be.
Yeah, go ahead.
Continue, please.
When you say hold, do you mean that no other one can actually take the physical NIC for itself?
Yeah, exactly. If it's a view, and think about not only this, think of a resource X, which can be whatever. It can be a parent for something else. I'm very generalizing it. It doesn't have to be interfaces right now. Because right now
there are different use cases. I mean,
exactly.
You will stop anybody from totally consume the parent. But then if you look at MacVLAN, you can put like 1 million on top of them. No, maybe not that much, but you can put a lot of them. You can just not give the parent away. And if you would put direct VLANs on top of the parent, then you will actually stop anybody else from putting the same VLAN tag again because it's consumed.
Oh, that's a fair use case. But I think this is
where we talked about that last week. It's a use case that is not that you will not do. You probably put a MacVLAN and then a VLAN on top of that one. But still, it is a use case where you actually use a part of the resource that nobody else can use again.
Yeah, exactly. But I think what we talked with just Lionel, right? I'm not sure whether you listened to that, right? On calling out the parent. I think this is where what you're saying, that additional like parentage, right? Because what I said, I can create a PF from PF. I won't create MacVLAN and then create VLAN on top of that even. So that's another level of, let's call it inception, where you can go,
It's a more normal use case for VLAN. I don't see why you would put the VLAN on top of a PF and consume that one, because it messes everything up a bit, I think.
Sure. But then I think that's another level.
Yeah.
What I'm getting at is this should still be the same as I'm saying, right? If I'm using a virtual child out of a parent, that should be inferred that the parent should be put a hold on it. Without I should not need to put a what I want to say, a explicit call in the claim that I want to use this parent. And additionally, Lionel, there is another thing, because you could call your resources like, okay, MacVLAN on ETH0. That's the name of the resource, right? And then you say IPVLAN on ETH0 or MacVLAN on ETH1, and so on and so forth, right? Then you have one new name of the resource that explicitly says, okay, I will reserve that one, right? And it doesn't have to be explicitly as I said, but this is just self-explanatory, right? What I'm getting at, then you have one resource explicitly calling out what I am going to reserve, what it will do, right? And then when I reserve that resource, it should call out and I should create a virtual interface on top of the ETH0 or 1 or what's not, whichever I picked. And that should be inferred that, okay, I am reserving that.
Will you give the resource what do you say, a unique name, and then hide all the parameters somewhere else, or do you want the parameter to be part of the resource claim? I think you can also say VXLAN with VNI 5 on
exactly. And I'm just calling out I think the possibilities, because it's up to the implementation. What my concern is, and Lionel, I think what my concern here is, if we are to then require additional parent interface, that puts because Lionel, what you want to do, that puts a special approach for virtual interfaces, and how do I have to define them in a template? This is where I assume then the template cannot be, and I'm heading towards, probably you see that I'm heading towards us auto creating the template, right? I know you referred to a case where what if we can just create that by the implementation and I can point to it. That is possibility, but then I wonder what other consequences that would have if I were to able to point to an existing template, right? Because this is something that we need to see of what will that be a consequence of. Keep in mind that pod network is to be the centralized item for and reference for all the other features, right? I think that's the goal. I hope that's still we are on in line around that one.
So
where
will the pod network describe, I mean, the stacking of different drivers and stuff, or where do we find that information? Yeah.
That's true, but that's fair. But what I'm getting at in terms of like even and then going further to implementation, what you're calling out, Anders, I want to kind of step back into what the pod network represents and what it's supposed to be. Like it's supposed to be the reference, the handle of the network that you want to assign to, right? And this is where even the gateway approach, right, that we want to kind of initially just kind of create a path towards cluster IP there, eventually put the pod network name somewhere in one of the fields, in some of the objects, right, to say, okay, this gateway for cluster IP is need to be assigned on network X, on pod network X, so that then I know, okay, which how that's aligned, right? And then that's just one aspect. Then the other aspect will be the network policy, same stuff, right? Where I can assign the network policy on a specific interface, rather interface of the pod or a network the pod is attached to, or I can apply the network policy to all the interfaces, right? If I don't specify
anything. The gateway should have multiple networks then, or should it not?
At once, I don't think it should have multiple. No, at once.
But otherwise, it's not a gateway. It should switch from network A to network B.
No, then that's not what I think. I think what you're saying in terms of gateway is you're coming from networking point of view. I am coming from how the gateway API is currently defined. Gateway is just an external IP fronting a service. It has nothing to do.
Isn't it the load balancer then? So usually you come in to the gateway, but then you select one target from that one. So it still would be multi-network.
I think beside the point, I want to just, I don't want to go into that under the discussion right now. I think that's something that we can follow up. I just want to get to the point that I think we are aligned in terms of what the pod network is. This is where I'm trying to be aligned at least on. I hope we are there, right? We are not, because I don't want to kind of diverge out of that. Do I get, are we aligned on that, what a pod network is?
Okay, define it for me.
It represents, it's a handle to the network, a resource or a resource belongs to. It's like namespace. You can think of a pod network a namespace.
Is it a handle for the pod?
Yeah.
Actually, and to make it easy, I mean, do we take the DPDK case into this, or do we only consider like IP stack, ifconfig interfaces, socket APIs? I mean,
it's up to you how you define pod network. We already said that as well, right?
Yeah.
Whether it's a L2, it's an L3, it's just a, you can probably go as far as, okay, specific TCP ports can be a network for me.
Yeah, L2, L3 and TCP is okay, because then we are still in the Linux kernel world. But when we start talking about DPDK device, then we actually leave that abstraction a bit.
No, we are not, because your pod network represents a physical network then.
Yeah.
I have a connection coming to, so a physical interface. And even not only that, it can either represent a physical interface, right? Or it can even represent a specific VLAN, L2 layer, right? Via the VF. Let's say my pod network represents this set of VFs that are assigned to a specific VLAN, out of which you can then create your DPDK stuff, right?
Yeah, that's
or I can represent the whole pod network with just an interface on the node. I can do that.
Yeah,
Let's
yeah,
say
you can, yeah, but the access methods will be very different if it's like
that's
if
up
it
to
is.
implementation, Anders. This is the thing. Please don't. Yeah, we are not putting any.
No, okay. I mean, but as long as we talk about kernel interfaces, it will be like a CNI that actually does the job. The implementation will be a CNI. When we talk DPDK, it's
It's
not
not
a
only
CNI
kernel.
anymore.
No, it's. I think what you're calling out in case of DPDK, this is for me a physical interface you need then
Yeah,
for the
like
pod,
a
right? Because
GPU.
DPDK is very application specific.
Yeah, it is. That's what I mean. It's a big difference. I mean, on what you attach to this network.
Fair, and that's true because
Mm.
not every pod network will have all the blows and whistles you can have,
Yeah.
right? But that's up to again implementation. That's where we called it out in the initial cap, where possible features can land or not. Most of the features that I'm calling out are optional on the pod network, I think. But go because we are kind of going back. I think I just one thing I want to call out: pod network is a representation of which domain you're in, right? I think what I said before is which network, and your definition of network is up to you what it is, right? Whether it's a physical interface or a specific L2 layer, a VLAN, or maybe a VXLAN, all a specific subnet, because you can
And
go
even
on
an
a by per
electrical
subnet.
interface, I mean, it's not really specified.
Yeah, but it's still an abstract handle to that specific
Yeah.
entity that you want to do. And having said that, then, and that's my, I think, core principle of the future for moving forward effort, right? That's why I was thinking the resource claim will be auto created. If that will still, if you are out manually creating the template and then pointing it through a pod network, if that won't break any of the kind of that principle and then any of the other features around that, then I think that's fine. Otherwise, I'm not sure whether that's okay, right? Having the non-auto created option in there. And then following that, this is where I'm kind of pushing back a bit on, treating the parent as a resource that you would want to reserve or call out in the template. I need to read through the CAB that you linked, Lionel, of what is the is that the approach that that it proposes, that to kind of call out the parent as a resource that you claim in the resource.
And the ability to create virtual devices.
Okay. So virtual devices, I do understand, right? But this is something that I kind of on the fence whether I should require to call out the parent interface for that, right? Because your resource, by implication, I want this type of resource, and you should be able to say, okay, it belongs to this parent, right? I think the other way to look at it, I think from how you're looking at it, you want to be more generic. I want to have a VXLAN interface, right? Or let's maybe more generic, easier. I want to have a MAC VLAN, right? This pod network is a MAC VLAN, right? And basically your class, you might have a class that says it's a MAC VLAN, but then your template will say it's an interface X, right? On across the nodes, right? And I think that's fair to say, right? But then if it's an interface X, your pod network right away can have that in the configuration, because your pod network, and that's, I think this is where, again, how you want to slice and dice the whole thing in the node, right? Because whether a pod network says, oh, those will be just MAC VLAN interfaces, and I can create them across any interfaces, and I just need to specify, and I don't care from the high level perspective of to which parent interface my pod connects to, because then I can abstract, right? It's just we have to be MAC VLAN, and okay, whether they connect to ETH0, ETH1, I don't really care. I just call
But
it
would
out.
that ever be the case, Malse? Isn't the purpose with multi-network to have like different physical networks with different domains? Of course, you care where you connect them.
That's my that's what I'm thinking. And in that case, your pod network should include and be called out, oh, this is a MAC VLAN on specific interface, right?
Fine. No.
So that's why, if that's the case, then your resource could be called it as such as well, right? It doesn't have to be fully generic. Oh, it's just a MacVLAN, right? It can be called MacVLAN on ETH1, and then I don't have to call out that such additionally a parent resource out of this. Lionel, I am throwing it with maybe pushing back on that concept, but and I need to read through the virtual, and I agree, if there is the virtual part is not there, it has to be added. That's beyond the point. My kind of call out is requiring to explicitly call out the parent for my virtual, right? This is something that I'm kind of on the fence on.
But yeah, I mean, maybe I misunderstood the part, this part that you are against. But if you're creating a MacVLAN, you need to indicate this to the scheduler that this MacVLAN will be based on ETH0, for example, and this ETH0
But that will be
should be
so. This is right. So this is where what I'm saying is, keep in mind, resource in this thing, it's an abstract thing. It's not like, oh, it has to be a MacVLAN. I can call the resource called MacVLAN on ETH0. That can be the name of my resource. You see, and then I don't have to call out that I need to resource. My resource is already has the name in it, saying which ETH, and that's just an example. It doesn't have to be. It can be coded in some ways. It doesn't have to be explicit name. This is what I'm saying.
But I mean, I mean, it's the same thing. I mean,
no, because then I reserve only one resource, not two. Unless I misunderstood you, because
we don't want to reserve this MacVLAN ETH0 that you created. We want to use it. We want to allocate a virtual device without claiming the device in
right.
the resource.
And the MacVLAN on ETH0 resource is the virtual device.
Yes, but let's say we create two MacVLAN on top of ETH0. They will use the same parent.
Yes.
They will not claim the thing that is in the resource slice.
No, they will claim that the resource slice will contain, I would assume the resource slice will contain something like MacVLAN on ETH0, that's the name, which is type of it will be of type virtual, and its parent is ETH0 resource.
Implicit because of the name.
Implicit, because that's how my implementation kind of advertises this.
But
right?
Maybe I misunderstood you. Recently, just for a second ago, I thought we put this data on the pod network itself was structured, but you mean that now that it's part of the naming of the resource?
It's exactly, that's where
Isn't that two
it doesn't
different
have to
ways
be.
of having?
It doesn't have to be the part of the. This is just my example of how, because keep in mind, those things that you see my cursor, right? This op extract and then device class op extract. This is something that the implementation owns. And I show the path how that goes, right? At the end, you receive a resource claim, right? That gets to the driver, right? And the question here is, how do I reserve specific, and because that boils down to how you implement things and how you name them, right? Yes, maybe the encoding this in a name maybe not the right way to do it, and it can be just part of the op extract, right? What I'm getting at, this can be the case. It can be represented as a single resource. It doesn't have to be called out as a two separate resources. You see, and then you can create in your implementation. You create a MacVLAN on ETH0 like resource, and it doesn't have to be the name. The name doesn't have to contain the on ETH0. This is just my example. Keep in mind.
But this example, it assumes a completely homogeneous system. When I'm playing around with DPDK, I often have the set where nodes are not exactly the same. You might have replaced one node.
And that's perfect, and that's fine, right? Your ETH0 can be a completely different indicator. It can be, okay, I want to have the MacVLAN only on this model and vendor of the device. It's all, keep in mind, this is all your implementation, and it's up to you how you want to slice and dice it.
But does it mean that we can use some generic labels and then we can translate that into like the
Generic
device
labels.
like in the implementation or something?
Then you said, I'm not sure. Labels. How
I
would you
don't
label
mean,
a?
I don't mean Kubernetes labels. I mean, could we have a symbolic name that we translate in the implementation to something else?
And I don't know whether that can be agreed across implementers. Across, you would have to have some standardized thing
Yeah,
that
but
says
then we
this is
should
what
have
you-
a name them like Node 5 ETH 3 MacVLON.
And to be honest with you, if you want to go even that with that granularity, you probably
Yeah.
could that as well. I'm not saying you
Mhm.
can't, because, and again, this OPEX struct, sky's
Mhm.
the limit, to be honest with you. You can
Mhm.
add there a node selector.
Yeah.
And your implementation says, okay, I will use those only for node selector. Keep in
Mhm.
mind though, that this is coming to the approach that I was kind of inferring initially, right? Where
Mhm.
your scheduler creates resources based off the template, not other way
Mhm.
around. I think this is the two approaches that kind of would have to kind of could happen. And I see that they can be there, right? Where either I create the scheduling resources based off of what pod networks there are,
Mhm.
or I create the resources at the initiation of the node without my knowledge of the pod networks, and I list out the whole thing that's possible to be created on that node, right?
Mhm.
Those are the two approaches. I think that's what Lionel has in mind. And I think, by the way, this is what DRA is doing, the latter, right? Where they just, I have a GPU, or I have a, let's say, PF,
Mhm.
and it can create up to, let's say, 100 VFs on it.
Mhm.
And I will advertise that, right? Because that's what my implementation
Mhm.
only cares about, and will list all those type of resources. And this is exactly what's being done there, right? It's not based on what your need is currently, it's just what's possible on the node. And I think that's fair as well to support, right? I'm not saying no.
That what you're describing is exactly how the device plugins from the network plumbing group is working already today. I mean, they
Right.
scan the system and put in resources, and then it's up
Not
to
exactly. They scan on what exists, right? They don't list out, but when you think about what you just called out,
Mhm.
they don't say, oh, this PF can have 100 or 1000 VFs.
It
We
does,
don't do
because
that today.
but you create the VFs first, and then they scan the VFs. I mean,
No, but that's post factum, right? I already, because I applied my intent. I want to have 10 VFs created. So
but if you go back to the device plugins that exist today, it's actually up to you as a system manager to create all the VFs when you boot the processor. It's part of the booting sequence, and then the plugin comes in and scan and say, I have this many VFs.
I'm not.
I can show. I can send you I have the exact place in the documentation where it says it's up to. It's not. It's outside the scope of the plugin to do that. It's up to the manager of the system to do this, to create the VF.
I think this is where I'm calling out, right?
Yeah.
But when I think like let's think about the SRLV operator, right? I think this is what we're talking about here, right? When it scans the node, when it scans the node, it scans the current state of the node. That's it.
Yeah.
It does not predict and doesn't say this PF can have 100 resources.
No,
it doesn't say that.
It scans
no, but
it
doesn't. But this is what's the difference. It doesn't say how many resources a specific PF can have. This is the prediction that's not there. There is a need to be administrator saying, okay, on that PF, go and create me 100 VFs.
But the VFs usually have their own PCI IDs, okay? And if you, as an administrator, set those up, so you give 64 VFs, and then you in the scanner, you say, I wanted to look for the VFs, it will do that.
But you have to pre-create them then still.
Yeah.
And
the
basically
says that it's up to you to do that.
But still, it doesn't predict. This is the difference.
No,
what I'm getting at here, keep in mind what Lionel and Lionel, I don't want to put words into your mouth, but correct me if I'm wrong. What you would want to do is I would like to call out before anything how many possible resources I can create on a specific parent. And I can say, okay, I can create 1,000 MAC VLANs. I can create 1,000 IP VLANs. I can create 4,000 VLANs. I can create 100 virtual functions. This doesn't do this. The operator doesn't do today. It doesn't predict and gives you capacity numbers for that PF. It just gives you what's the current state. This is what I'm referring to, and this is the difference, right?
I see a problem with that as well. You know, say that you can have 32 VFs. It's up to you to put the driver on them. If you want to have a VFI or PCI for DPDK, or if you want
there is that. That's what I'm getting at is either you predict and provide capacity based on your driver and its capability to list out things, or you list out resources based on the current requirements. And the requirement is I created a pod network pointing to with these parameters that it wants such resources. And so that's the two kind of ways that we want to you can go by, right? And I'm calling out because right now what we did in at Google, this is what the first approach. That's why I'm kind of maybe I am a bit skewed around that one, and I apologize. But this is what we do today, right? You create a pod network, and we will tell you how many resources you can have on each node for that specific network, and only that or all the networks that are available in the cluster, right? Rather than okay, go and generate all the possibilities and combinations of whatever there can be and list all that. I think that's true. Keep in mind then your driver has to be very robust to be and handle all the possibilities, right? What you can generate, right? There is that aspect, right? I think that's maybe not so hard, but then you have to be cognizant of that, right? And that's kind of predictability versus reacting based on the desire, right? Because I have a pod network that desires this type of configuration. Okay, I will, based on that configuration, let me check what's available across the nodes. So that's the difference, right, in the approach. I think both are fully valid. I'm not saying they're not. I think pick your poison at that point. I think it's just I am pushing towards one to kind of ensure that it can be easier on us here on how we define if we were to auto-generate the resource claim templates, is that work, right? And how that kind of, is that going to be difficult or not, and how to configure that. But on the other hand, we can always, something that I mentioned last time, we can always get the go and define some standardized op extract parameters that say, okay, you can specify some parameters so that I'm gonna pass them to the generated template, right? And then they're that, right? So maybe that's thing that can be done, that can kind of control all those pieces. Let's get back to this. So Lionel, the virtual device. So let's I think there's a lot of how can that be done and how that kind of affects. Let's get engaged with that. Is that something that's currently internal, right? What you're saying? It's not an official cap yet, right?
Right. It has been presented yesterday during the device management meeting. People were, I think, happy about this initiative. And the person who created this document is waiting for the recording to open the CAP issue and the CAP PR.
Oh, okay. Okay. We took a lot, I think. But yeah, I think your item is next, Lionel, as well.
Yes, I brought this topic last week or so. It's because I was saying that I will bring it in the SIG network, which I did. So it's about having a generic endpoint controller that would be outside of the core of Kubernetes. It would be a new repo where we could
We
have
got
this
approval,
generic
right, for
endpoint.
the repo, right?
Right, exactly. So the idea is to have a generic endpoint controller that can be used for example, multi-network. It could be reused for Multus, for example, also. I mean, with some a bit more implementation.
You did listen to Tim's last comment, though, right? That you are going to vendor the existing piece.
Mm-hmm.
That's okay, right? I assume that's fine. Is that the plan, or that wasn't the plan? Because I thought that wasn't the plan.
I mean, the idea is to sync first with the official endpoint slash controller, and then if there is a use case in Kubernetes for this, it would be already there, and it's something that we will not have to implement it in multi-network. I think it's a good thing.
No, definitely.
I think like Pooja had this idea last week about the endpoint selector for Gateway API. I think it could be reused there. Some Cilium people were interested in similar idea. So the next step is for me is to create or to send an email to SIG Network and to do the creation of the repo.
All right. That's fair, because how would that work is like Pooja's idea of in the gateway is to add the endpoint slice object, not endpoint, sorry, endpoint selector object. So that's something that we need to have a controller that's going to listen on that rather than on service, right? And then based off that, create the accordingly the endpoint slice then at the end, right? And then if it's some special case, instead of going to the pod's IPs in the pod status, go to the resource claim of the pod, right? For the specific, of course, pod network at that point, right? So I think that's the goal, right? The ultimate goal, right, Lionel?
Yes, exactly.
Okay. Let me write it down. For IP in general. And that. Any other questions to this? All right. Do you have any? I think you have some doc on the CNI itself, but do you have anything on this controller yet, Lionel? In terms of like design or doc to read on?
No, I have an implementation.
Oh, okay.
That's the only thing, because
Okay,
of
gotcha.
the cap. Oh, yeah, I have. I have the cap.
Oh, the
half.
cap that was previously. Oh, okay, that guy. All right. Yeah, I'm familiar. Okay. And then I think no other topics. So, Doug, you still here? So I think the gist that we kind of in the meeting agreed on that, yes, the pod network, we want to have a default network so that all the networks, all the stuff that's done networking related in Kubernetes cluster can be done through this. And I think what we called out 2 modes, hard and soft, because what I just said is tricky, because you'd have to redo in some ways of how the cluster exists, right? What it means is if I do everything through pod network, there is no such thing I'm doing something through CNI anymore, right? Everything goes through pod network, DRA, whatever I list there, and only those interfaces get added. If I don't specify anything, I auto add the default always to the pod as a resource, and then I have the same path always, right? So that's, I think, the ultimate goal is there, but it comes with a caveat. You're gonna have to recreate your nodes, what's not. So I think something like call out for how hard versus soft approach to this is, I think, good, because not everyone would want to, oh, I'd add this and redo their own whole cluster to get it enabled in such a way, right?
Oh, okay, this is helping me, and it's very interesting to me. Okay, so do you see the soft mode being able to like kind of have both? So like if you don't specify it, you get the CNI treatment. If you do specify it for default
Yeah,
network,
we would have to define that, right? Because
yeah, okay.
because how we go about that, right? The implementation wise, right? With the hard approach, we just go and let's say create some dummy CNI that does nothing, right? Or somehow trick into kubelet. I'm not sure whether we can change anything in kubelet for this. Initially, I
And
would
you
just
know
say
what?
just
I swear I've seen in one of Lionel's POCs where he disabled CNI specifically in Containerd. So I mean I think it's possible to configure your cluster that way where you just don't have CNI or CNI isn't executed.
okay. So ways to do it, of course. Okay. But I think the goal here is that you have one or the other because of changing containerd configuration. It's a big thing, I would say. Especially if you have an existing cluster, or if you don't, then your installation has to change quite severely to kind of address, okay, now no CNI, how do I then bootstrap the whole thing accordingly? So that's a big change on your cluster creation, what's
Well,
not, right?
then envision this to where the primary CNI is pod network aware, right?
Or that, yeah,
So
eventually.
like you could, and so yeah, maybe this is something we should formalize as we like spec out how pod network works with default CNIs.
Yeah, yeah.
If you will, is yeah, it's I mean that's something that we could kind of write in there to open the door to you, right? To say like
Right.
in the soft mode, a primary CNI may be pod network aware.
Yeah.
Yeah. This will be the
So
first
something,
time I think that we address CNI specifically in our specifications, because otherwise we kind of said it's like an implementation detail, but I mean it makes sense, like it's a reality that people deal with.
yeah. So because that's what it trickles down to, right? I think initially we can just look at the hard option because I think it's easier. That because it means you have to restart node or redo some things and some approach to get to the stage where you have a proper DRI installation, and then yeah, it's deployable in that way where everything goes through pod network, right? And if you don't, we have a, let's say this approach will have as well a webhook for the pod, a mutating webhook for the pod. If I don't have any resources called out, I will always add you a default one, right? And then whenever we would require all the pods to be restarted. When that happens, we will auto populate and add you the and we will add you the with mutating webhook the resource, right? So that every pod now has the default network called out in it, right? So that's something along the lines what would the hard mean, right? So that we ensure that all the pods are moved around, so that we add the default pod network to them, and then they get the proper IP kind of interface, right? And basically, if the default webhooks, the mutating webhook kicks in, then your driver should basically call out your default CNI in some ways, right? That should be then the same path as you had it when it had the CNI, right? That's how it should be eventually. And then with that, then you can then add other interfaces, handling them differently or what's not. Sky's the limit at that point, right? I think that the problem is how you bootstrap, how you apply this thing in a hard way to a cluster where, okay, instead of going through this default kubelet CNI contain a CRI CNI path, you go through pod DRA, right? And then your NRI or what's not, right? Doing all the stuff. And then tricking the kubelets to say, yeah, CNI is ready, right? Because they rely on that one still. So
yeah, that's another question. But yeah, certainly we should continue this discussion and figure out how we want to spec it out. I'm interested in this functionality, and I want to see how this stuff comes together. And I also I want to make sure that two things. One, that, you know, administrators don't have like a black box situation where they're like dealing with a black box on how things are configured. And then also I want to make sure that people can integrate solutions together with it, right? So that it's not just like one kind of like takeover of one implementation and people can't put them together, because this is something that's good in CNI, is it can be modular. But yeah, this is good stuff, and I won't keep I know we're over time, so I'll quit my blabbing, but thank you for covering this for me.
I think, and the golden rule is this. I think giving the VPC-like feel to Kubernetes cluster. I think that's what coming from cloud providers, right?
Yeah, everybody.
I
think everybody wants something like that, and it's like even some of the initial stuff that you talked about with like isolating tenants, right? So like that kind of stuff, I feel like that's very intuitive for people. So yeah, on the same page for sure.
So I think that's the goal. Okay, so that's the kind of gist. All right, we are at time. Right, thanks everyone. Let's see next week.
All right, Pete.
Bye.